All right, so we're going to move here to 1.5. I'm going to label these notes 1.5a because I'm going to cut this section in half. Kind of do the first half and the second half in the notes. So 1.5a is solving inequalities. So we're getting into some symbols and things that you should have seen before, but we're going to kind of review those, and we're going to add something that's a little bit new. We're going to talk about interval notation and set notation. And for the most part in this class, we'll use interval notation. Set notation you could see later on in pre-calculus, calculus, or even on the ACT. So it's something I want to introduce to you and show you, and just things that you're familiar with. So you should know these symbols, okay? X is greater than 4, X is greater than or equal to 4, X is less than 4, X is less than or equal to 4. And then when we graph those things here, for X is greater than 4, we have an open dot. The open dot signifies that 4 is not included. And the X is greater than or equal to 4 has a closed dot. And again, it's both those arrows are pointing to the right because those are where the numbers are greater than. So if we go to the next slide here, you're going to see that I have it blank. So we're going to look at X is greater than 4, and we're going to talk about what is called interval notation. Okay, so for interval notation, we're going to use, no, not an A, notation. Jeez. Okay. We're going to use when it is a less than symbol or a greater than symbol, we're going to use parentheses to show that it is not included. So we use parentheses. If it's a less than or equal to or a greater than or equal to, we're going to use a bracket. So I'll show this up here for interval notation. And we're just understanding that all we're doing is taking a number line and scrunching it down in between two numbers. So when we say X is greater than 4, I look at the greater than symbol. Greater than means I use parentheses. So I'm going to start the solution set at 4 with a parentheses. Why did I use a parentheses? Because it's just a greater than. And then that is a comma, and it's going to go all the way to positive infinity. Again, we never put a bracket around parentheses because that's not a real number. It's just a concept that the numbers keep getting larger and larger. So basically what I did here was take, where did our number line start? Oh, goodness gracious. Hold on. Sorry about that. I'm getting used to this pen and mechanics here, so stop it. Okay. Let's undo that. Okay. So basically what we did is we had a number line. Okay. My solution was at 4. I had an open dot, and it's everything to the right. So what I did was I put a parentheses at that 4, and how far does this go? It goes all the way to infinity, and we close that off. So we're basically taking a number line and just crunching it down. Okay, so now if I have X is greater than or equal to 4, the greater than or equal to, because it is included, tells me to use a bracket. And it still goes to positive infinity because it's greater than, so it'd be everything to the right. I have X is less than 4. Less than 4 means it's smaller than 4, so the numbers 3, 2, 1, yada, 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 go on and so forth. So we actually always want to go from left to right. So this would be from negative infinity to 4. And would I use a parentheses or bracket around the 4? I would use a parentheses because it's just a less than, and we always use a parentheses around infinity. X is less than or equal to 4 goes from negative infinity to 4. And on this one, I use a bracket because it is included. So interval notation is just basically taking a number line down and showing all those numbers in between. We use a parentheses if it's not included. How do we know if it's not included? It's not included if we have a less than or greater than symbol. And we use a bracket if it is a greater than or equal to or less than or equal to, that means it is included. So instead of graphing these like we did in Algebra 1, we're going to just use interval notations on our answer when we solve these. So we're going to go through a few problems. We're going to solve these. And in those problems, we solve them just like we would equations. There's only one subtle difference, and that's in step 5. In the very last step, if you multiply or divide by a negative, you're going to flip the inequality symbol. So if it becomes less than, if it starts less than, then it will become greater than. If it's greater than or equal to, it'll become less than or equal to. We're going to do a couple of examples that show that. So I've got 2 examples here. This says 5 minus 2, parentheses n plus 2 is less than or equal to 4 plus n. So I'm going to go ahead and try to get n by itself. So I've got parentheses, so I'm going to distribute the negative 2 to both of these terms. So this would be 5 minus 2n minus 4 is less than or equal to 4 plus n. On the left-hand side, I have like terms. I've got this 5 and this minus 4, so I've got 1 minus 2n is less than or equal to 4 plus n. I'm going to get the n's on one side. I'm going to choose to move the n's to the right side. I'm going to add 2n. So that would give me 1 is less than or equal to 4 plus 1n plus 2n is 3n. I'm going to move the 4 to the other side. I've got 1 minus 4, which is negative 3, is less than or equal to 3n. I'm going to divide by 3. And did I divide by a negative here? No, I divided by positive 3. So that would just give me negative 1 is less than or equal to n. Okay, now when we write this, I want to write the variable first. So this is actually saying n is greater than or equal to negative 1. You can see that back to elementary school, that it's eating the n. So the kind of the alligator is eating the n. So you got to make sure that it's eating the n here. And this reads n is greater than or equal to negative 1. So if we were to graph this, we would put a negative 1 because it's included. We would close it in and it's greater than or equal to, so it's everything to the right. With interval notation, the solution starts at negative 1. Is the negative 1 included? Yes, because it's a greater than or equal to symbol. So I use the greater than or equal to symbol, and that would go all the way to positive infinity because it's greater than. Again, from left to right, where does the solution set start? At negative 1. Is the negative 1 included? Yes. How do I show that? With a bracket. Okay, so let's take a look at this next problem here. Okay, it says 1/3 7a minus 1. Again, we're doing the same thing. We're going to distribute. Nothing changes there. 1/3 times 7a is 7 over 3a. 1/3 times negative 1 is minus 1 over 3. That's going to be less than or equal to 2a plus 7. So same thing. I'm going to get the variables on one side. So I'm going to subtract 2a. Okay. Now, this is where you may need to get a calculator out, or if you're good with fractions, you can do that. But 7 over 3 minus 2a is the same thing as 7 over 3 minus 6 over 3, right? 6 divided by 3 is 2. So now I got a common denominator, and I would just get 1 over 3a minus 1 over 3 is less than or equal to a positive 7. Again, those canceled on this side. So now I'm going to add the 1 over 3. I'm going to add 1 over 3. We can't be afraid of fractions here. We're getting into algebra 2, so fractions will be a part of this lesson. So again, if I've got 7 plus 1 over 3, it'd be 7 1/3. Or if I wrote it as a fraction, 21 over 3 is 7 plus 1 over 3. That would be a 22 over 3. And then now how do I get rid of a fraction? I'm going to multiply by the reciprocal. So over here, that whole thing cancels, and I have a is less than or equal to. I'm going to multiply here. These cancel, 22. So that says a is less than or equal to 22. So less than or equal to tells me that it's a bracket, and it's less than, so I'm going to start at negative infinity in my interval notation, and I'm going to go to 22. Because it's less than or equal to, I'm going to put a bracket around the 22. Again, one thing students get confused with, why isn't it a bracket around the infinity? We never put a bracket around infinity, positive or negative. It's always just a parentheses. All right. Take a look here at the next example. So here, again, I'm going to distribute. That would give me a negative 6x plus 15 plus 1 is greater than or equal to 4. I've got like terms here that I'm going to combine. So negative 6x plus 16 is greater than or equal to 4. I'm going to subtract 16 from both sides. Again, this is just following those steps. Okay, I'm going to divide by negative 6. Now here is where you have to pay attention. I'm dividing by a negative. So that means I'm going to take x and I have to flip the inequality. So here I'm going to flip. Why am I flipping? Because I divided by a negative. Okay, so I'm going to flip the inequality. It was greater than or equal to. It's now going to become less than or equal to, and then we just do the math. Negative 12 divided by negative 6 is a positive 2. So this now reads x is less than or equal to 2. So less than or equal to tells me that's a bracket. Less than or equal to tells me I start with negative infinity, and I go to 2. I put a bracket around the 2 and a parentheses around the infinity because I never put a bracket around infinity. It's always a parentheses. Okay. So this is the first half. Again, we're going to really work, practice the interval notation and all these problems that you do in Delta Math. I want you to write down interval notation. We will use this throughout the rest of the year. So it's not something that I'd like you to ignore.